Hello everyone, this is J12 question 2 of our Leetcode activity. Isomorphic strings. Given two strings S and T, determine if they are isomorphic. Two strings S and T are isomorphic if character S can be replaced to get T. All occurrences of character must be replaced with another character while preserving the order of characters. No two character may map to the same character, but character may map to itself. So as simple as here, egg add. So here E can be mapped to A, G can be mapped to D, and if we replace all occurrences of E with A and all occurrences of G with D, we can get add from the word egg. So this is true. Now see here, F11, B23. Now F can be mapped to B, 1 can be mapped to 2. So if we change F11 by replacing all F with B and all 1 with 2, we will get B22. But we can never get B23 because 1 cannot map to two things at a time. So this is not possible. But look here, P can be mapped to T, A can be mapped to I, E can be mapped to L, R can be mapped to E. So if we replace all P with T, all E with I, all E with L and all R with E, we can easily get the word title from paper. So this will be true. So how do we solve this? So think of an approach. See a letter A should be mapped to B, then letter cannot be mapped to anything other. So basically, we have to iterate through both the words and check if this one-to-one mapping is possible between letters. If this mapping exists, then it is true. If this mapping does not exist, then it is false. So how we will do this? We'll make an unordered map of character M1 and character M2. So we iterate through both the strings. And why do we just require s dot size? Because both the lengths are equal. So character A is equal to SI, character B is equal to TA. So we are taking the same index letters from both the end. As we can only replace this, as we can replace the letter here to get two letter in T. So if M1 dot count A and M MP1A not equal to B. So what does this mean? First of all, dot count A. So MP1 is our map. Dot count A. This will return 1 if A, that is what is A? The letter at ith index of S exists in the map. So now firstly let us consider this exists. So this returns 1. And if value, so this is the key. So count C looks for the key. So the key exists. Now MP1 A not equal to B. That is, what is B? The equivalent character at the ith index of T. So the value associated with the letter at the ith index of S is not equal to the letter associated to it at the ith index letter of t, that is mp1a is not equal to b, then we return false, because this just shows us that this mapping is not possible. So we directly return false. Again, mp2 dot count b. So this mp1 we are maintaining for s to t, and this we are maintaining for t to s. And why we are doing that? Because multiple occurrences of same letter in s. So for different indexes, they can be mapped to different letters in T. So with just one map, it will always return true for even though the same letter B is being mapped to two different things. So we need to keep in account two maps, one for S to T and one for T to S. So now we check for T to S, which is MP2 count B. B is character in the ith index in T and an mp2b not equal to a, that is the value b exists, the key b exists, and the value associated with the key b, is it equal to a. If it is not, then mapping is not possible, directly return false. Now if these both conditions are not met, first first reason can be the key does not exist, or the value at the key is actually equal to the desired value, the value which we want. So, for the case this does not exist, we add it to the map. And if they both exist and their value is also the desired value, this both will not change anything as we are reassigning the same value to them. But these both are important for the key does not exist. So this will add that key to our maps. And at the end, if iterating the whole strings, both the strings, and we do not find any mismatch in our map, that is we have not returned false for any of these two conditions. For all the characters in S and T, we return true at the end, as we have proved that the mapping is not mismatch anywhere, that is mapping exists, so we will return true. So this was the approach to solve the question isomorphic string. Thank you.